About allowable stress design. The first thing we need to really talk about when we talk about design is an idea called factor of safety. And this basically stems from the fact that your measurements can be inexact. You could have some fabrication errors. You can have some unaccounted or unknown loadings. Materials can deteriorate over time. There can be variation in materials such as wood, different gaps and things like that. So our models aren't always exact. Okay, so that failure load isn't necessarily what we should design for, because it's not an exact model that we've created. Okay, so the factor of safety is essentially the ratio between that calculated fail load or stress divided by what we're going to call our allowable stress or our allowable load. Okay, and that allowable load is always going to be less than the failure, so we don't push it too much. So this factor of safety is always going to be greater than 1. If it's less than 1, it's going to break before it gets up to the fail. So we always go bigger than 1, and it keeps going up higher and higher, say with when we've got like human interaction. If people's lives are in danger, you're going to want a higher factor of safety. Or if you aren't really certain about your model, you're going to want to bump up that factor of safety a little bit to account for any uncertainties that might come with your model. Okay, so to figure out this allowable stress, you determine what kind of factor of safety you need, and then you can basically design connections by choosing a proper area for the stress, right? You'll know based on the model what kind of loads you have, then you basically say, okay, I need this sort of an area to hold that load. So, it's just rearranging that stress equation that we had before. So I'm just going to go through a couple of things here. First, in a direct shear sort of model, we talked a little bit about this. You have what's called a single lap and a double lap joint. So a single lap joint would be right here, where the applied load F is the same as the shear force going through a bolt that you have there. Okay, whereas a double lap like we have here, which is a pretty common situation that we would have, you see I've got one force going that way, okay, but when I've got this double lap here, the shear force is actually half of that. Okay, so there's not as much shear force going through through the bolt, because it's basically, I've got two sections that it's holding. Okay, so that applied force gets reduced by half, basically. Okay, here I have what we're calling bonding shear. So if this is like attached into a wall, okay, now my shear is actually basically on the circumference of that. So the area looks a little bit different. It's just based on the diameter or the circumference times the length, essentially. So again, you just have to look at how, what's actually being sheared. So that's a little different way to look at it. Another type of stress that we haven't really talked about is bearing stress. And this is basically the stress between two things that are touching. So, if I have a column like this acting on the ground, right? So it's the area between those two, and there's a stress, that can lead to cracking and things like that. So oftentimes we'll put a base plate like this to reduce that bearing stress, or increase the area at which the force is being acted upon. So to reduce like cracking and things like that at that interaction. Okay. So again, the whole idea behind this is figure out what your allowable stress is, and then design your system so that the area is large enough that it can support the load and keep the stress below that allowable stress that you have there.